First and foremost, you must memorize the identities I'm writing on the screen for you. Some of the systems in the world, they provide you certain identities, but some parts of the world you need to memorize all the identities, and people find them very difficult. So the trick is, do not memorize them at one go. Do what? Whenever you are solving an identity or proving an identity, keep the identities in front of you. You will use them so many times. If you suppose practice 50 identities, they are enough for you to memorize these ones. Okay, so just keep in front of you, keep on using them, and you will memorize it. So do not specially take your time to memorize them, but when you use them multiple times, you will get used to them. So these are the 4 identities I have written here. The fifth one is sine theta over cos theta equal to tan theta. From this first identity, there can be 2 more identities produced, which is cos square theta is 1 minus sine square theta, and sine square theta is 1 minus cos square theta. If you manipulate this identity, we get this. So these 5 identities you memorize by practicing, and you will never feel bad about not being able to prove an identity. Tip number 2. Whenever you have 2 parts of an identity, left hand side and right hand side, and they have no connection, convert them into sine or cos, and you will be able to connect them somehow, because sine and cos are somehow connected to all other trig ratios. Let me give you an example. Here's one. So here we see that cos x is there and cot x is there, secant x is there, tan x is there. All of them are not related. Secant and tan are related but they must be in squares. So the best part is convert cot, secant and tan into sine and cos. So what will I do in this question? I will do this. Cos x over sine x, that is cot x. Next, cos x plus 1 cos x over sine x. And I need to prove it is equal to 1 over cos x minus sine x over cos x. But definitely this one will be simplified to this somehow, definitely. Tip number 3. Whenever there are 2 terms of trig ratios are adding or subtracting on one side, and there are 1 or 2 terms which are multiplying on the right side, in that case you must convert the 2 terms on the left side or right side, wherever they are, into fractions, because fractions help us to merge the 2 parts. So if I look at the first one, tan x is sine x over cos x and cot x is cos x over sine x. Now I can merge them by bringing them together by finding their LCM. So if I multiply this by cos, multiply this by sine and up as well, they will get merged, right? Because they have same denominator and they will become one entity. This will help us to merge them and they will become one term. Let me show you here to complete this one. Sine cos square x over sine x cos x. This numerator is 1 and it will over sine x cos x. Now 1 over sine x is cosecant x, 1 over cos x is secant x. So there were 2 different parts adding. We merge them with the help of denominators. Tip number 4, polish your knowledge of the algebraic identities you have learned in previous classes. These will be very handy when you need to merge different denominators or you have to expand something. It will not only save time but make your work very clean. Let me give you an example. Here is an identity I have to prove. Obviously, there in tip number 3 we talked about if two parts are adding or subtracting, denominators help us to merge them, right? So the same thing we'll do here. We'll multiply the denominators by each other so that the LCM becomes their multiplication. So I will multiply 1 minus cos x here and 1 minus cos x on top. Similarly, I will multiply 1 plus cos x on numerator and 1 plus cos x in denominator. But look, here it is 1 minus cos x, this is 1 plus cos x, and this identity will be useful here. If you start expanding it, it will not only make your work very confusing, but also you may make mistakes. So memorize or polish them before you attempt identity proof. Tip number 5 and the final one is that if the right hand side is more complicated than the left hand side, then work on the right hand side. There is no rule that you have to work on left hand side and get the right hand side. You can work on right hand side and prove that it is equal to the left hand side. So choose the one which is more complicated and convert it into the simpler one on the other side. Identity 1A. It has tan and cot on the left side, secant and cosecant on the right side, so we can connect them by sine and cos. So it will be sine x over cos x plus cos x plus over sine x, that is LHS. So to combine them, it will be cos x sine x, and here it will be sine x times sine x, right? Because I have to multiply with this here. So it will become sine square x plus cos x multiplied by cos square. So cos x times cos x will become cos square x, which is 1 over cos x sine x. Now I can write them separate. 1 over cos x multiplied by 1 over sine x. And that gives us secant x, which is 1 over cos x multiplied by cosecant x, which is 1 over sine x. This is RHS. P part. Sine x plus sine x cot x is equal to cosecant x. So again we have to connect them through sine and cos. So LHS. Sine x plus cos x over sine x. Now we have to combine them because we have just one term on the right side. So I'll put sine x bottom and square on top. That will make it, we'll have same denominator. So sine square x, and so it will be sine square x plus cos square x over sine x. Yeah, because both of them have same denominator now. And cos x times cos x will be cos square x, which is 1 over sine x, which is cosecant x, RHS. Okay, C part. We have cosecant and sine combination and we want cos and cot. Again, we'll take the help of cos and sine. So 1 over sine x, that is cosecant x minus sine x, this becomes LHS. Yeah. So I'll put again sine x bottom, sine square x on top. So it will become 1 minus sine square x over sine x. We know 1 minus sine square x is cos square x over sine x. So now I can separate cos. So I'll write cos x over sine x times cos x. and cos x over sin x is cot, and cos x is cos x. That is RHS. Move on to D part. We have secant x, cosecant and cot on the left side and tan on the right side. Again, we'll take help of sine and cos. So secant is 1 over cos x, cosecant is 1 over sin x, and cot is cos x over sin x. This is LHS I'm focusing on, okay? So cos x sin x is the denominator here, just sin x, so that means we have to multiply by cos x here and cos x here. So 1 times 1 is 1 minus cos times cos is cos squared x over cos x sin x. 1 minus cos square sin square x over cos x sin x. So we can cancel one of the sine with this sine and we are left with sine over cos, which is tan x RHS. Okay, let's move on to 2a now, which is 1 plus secant x, cosecant, cot, tan. So again we'll connect them with sine and cos. So LHS will become 1 plus 1 over cos x, cosecant x will be 1 over sine x, minus cot x, cos x over sine x. And we have to prove this is equal to tan x. Alright. So let's change this 1 to cos x over cos x, so that I can combine these two terms. So it will become what? Cos x plus 1 over cos x. And they have same denominator sin x, so I'll put sin x here. 1 minus cos x on top. Alright. So the numerator will multiply with numerator, denominator will multiply with denominator. So here we have this identity kind of situation. A plus b, a minus b equal to a square minus b square. This is an identity, as I told you in the tricks. This is what we'll use here. So it is a plus b, a minus b situation here. So it will be 1 square, which is 1 minus cos square x. That will be the numerator, and denominator will be cos x sin x. Alright. 1 minus cos square is sin square x. Cos x sin x. Now we'll separate sin x because we want tan x, right? So sin x we can write separate. Once I will write cos x here and once I will write sin x here. They can cancel out. We are left with sin over cos, which is tan x RHS. Proven. Alright, let's go to B part. B part is something similar. Again, we'll do the same thing. 1 plus cos x will be 1 plus secant x will become 1 over cos x. And 1 minus cos. Oh, it is easier one. Cos x. This is what we have to prove as sin x tan x. So we'll do something like what we did here in A part. So cos x over cos x here. So that the denominators are cos x. So we can combine them. Cos x plus 1 over cos x. And 1 minus cos x. Same situation as we were here. So they will multiply, it will give us 1 minus cos square x over just cos x, which is sin square x over cos x. We'll separate sin x again, sin x, and only 1 cos x. This is tan x, and sin x will remain sin x, and this is RHS. You can see here. This is RHS. Let's move on to the C part, 2C. Alright, tan square, secant square, cosecant, cot, all of them can be connected with sine and cos again. But I can see a straight connection between these two. So we know that tan square is secant square minus 1 minus secant square x plus 2. This is what the LHS will become. Secant square and secant square cancel. 2 minus 1 is 1. But our RHS is not 1. So let's prove RHS also equal to 1 and we'll prove that they are equal. So there is an identity for cosecant square also. So it is cot square, this is RHS, okay? cot square x plus 1, that is cosecant square x, and then additionally we have minus cot square x. They cancel out, we are left with 1 on right side also. So LHS, RHS both gave us 1. Okay, in D part we have squares here because we had squares in C part, so we could do them directly, but we don't have any squares on the left side. But I think if we multiply these two by the same identity, a plus b, a minus b, we'll be able to do it. So let's do 2D. First multiply these two brackets and we'll get cot square x minus tan square x. This is what we'll get. This is the LHS. And now we know cot square is cosecant square x minus 1. Tan is secant square minus 1. Alright, so cosecant square x minus 1. If I open this bracket, it becomes minus secant square plus 1. Minus 1 and plus 1 will get cancelled out, and we are left with cosecant square x minus secant square x, which is RHS. Let's start with 3a, where in LHS they have tan and cot, and RHS they have sin and cos. So of course we will convert them to sin and cos in LHS. So let's focus on LHS. So 1 over sin x over cos x plus cos x over sin x will be the LHS. Now let's focus on denominator only. The denominators of the denominator have different values. So let's multiply this with sine and multiply this with cos so that we can merge them. So it will become what? Sine times sine. This one will become sine square x plus cos times cos, cos square x, and because they have same denominator, we multiply these two. It will be cos x sin x. Now sine square plus cos square x will be 1, so it will become 1 over cos x sin x. And now this is reciprocal of a reciprocal, that means this will become the numerator now, so we can write it as cos x sin x, and that is RHS. Let's go to B part now. Sine square plus cos square, nothing can be easier than this. LHS, sine square and cos square is 1, and 1 over cos square x, and that is secant square x. Voila, so fast. This is RHS. Okay, C part. Sine square x cos cube x, and we have cot on the right side. So let's take cos x common from these two, this and this. So if I take cos x, that is LHS, okay, I'm focusing on LHS. Cos x is taken common, so sin square x will be left here, plus in this cube, one cos is already out, so cos square will be left inside, over sin x. This is 1, so we will be left with cos x over sin x, which is cot x. RHS proved. Okay, D. 1 minus cos square x on LHS, this one is sin square x. Secant square x minus 1 is an identity, it is tan square x. So now we can write sin square x over sin square x over cos square x, right? That is tan square x will become this. Now they're dividing, okay? So we can write this as sin square x divided by sin square x over cos square x. So it can be written as sin square x multiplied by cos square x over sin square x. They cancel out, cos square is left, but on RHS they want 1 minus sin square x, and cos square x actually is 1 minus sin square x. proven. Okay, let's go to E part. 1 plus tan square x. This 1 plus tan square x on LHS will be secant square x. That is the identity. Divided by tan x. Okay, now we can separate secant, because if you see RHS has secant x, 1 secant x. So second one we want cosecant. So we will separate this. Secant x is reserved. So secant x over tan x will be the rest of it. Yeah. So let's use sin cos again for these. So it will be secant x multiplied by 1 over cos x, that is secant x, right? And sin x over cos x. Since they have the same denominator, we can cancel them. Cos x and cos x can get cancelled out. Or you can use the process like this I used in this one. We are left with 1 over sin x, which is cosecant x, and that is RHS. Let's move on to F part. Okay, it says sin x over 1 minus cos x on LHS, and 1 minus cos square x is sin square x. So we can cancel this sin x with 1 over sin x. We will be left with 1 over sin x, which is cosecant x. Alright, G. Sin x tan x square, okay, and we want sin cube. That means again we'll have to convert sin square on LHS to sin over cos. So G will be sin x multiplied by sin square x over cos square x divided by 1 plus tan square x is secant square x. Now the numerator sin x and sin square x will make it sin cube x over cos square x, and secant square is reciprocal of cos. So we can write 1 over cos square x, and denominator of numerator, denominator cancel out. We are left with sin cube x, which is RHS. Alright, H. Okay, 1 minus secant square x. We know secant square x minus 1 is tan square x, correct? But it is opposite, 1 minus secant square. So minus is here and plus is here. That means we have changed the sign. So we can write minus tan square x. So we will write minus tan square x. That it will be the numerator of LHS of H. 1 minus cosecant square x. We also know that cosecant square x minus 1 is cot square x. Again, its signs are changed. That means this is negative, this is positive, so this will become negative. So it will be minus cot square x, that is the denominator. And we also know that 1 over tan x is cot x, that is the reciprocal. Yeah, so we can write here minus and minus can cancel out. Let's get rid of them. Tan square x will be the numerator, denominator will be 1 over tan square x, and denominator of a denominator is numerator. So tan square x multiplied by tan square x, which gives us 10 to the power 4x, which is RHS. Alright, what is next? I. Let's focus on I. 1 plus sin x, 1 minus sin x equal to this. Now, the right side is more complicated. Yeah, so let's focus on RHS. So, sin x over cos x will be tan x in RHS, right? So let's write sin x over cos x plus 1 over secant x, its reciprocal is cos x. Alright, so the denominators are same, so we can write sin x plus 1 over cos x square. So can we write this as 1? We can change, we want 1 plus sin x, right? 1 plus sin x, the numerator square over denominator square, right? Now 1 plus sin x square will remain what it is, but cos square is 1 minus sin square x. Now we know an identity which is a square minus b square equal to a plus b and a minus b. Yeah. So similarly, if we keep the numerator what it is, but denominator we will use this identity, because here we can write 1 square minus sin square. So 1 plus sin x and 1 minus sin x. So 1 of this 1 plus sin x will cancel with this one. We will be left with 1 plus sin x over 1 minus sin x, which is RHS. And finally j. We can see here cos x, cot x on LHS, secant, tan, and there is no square, so there is no direct relationship, so we'll have to change them to sin and cos. So it will become cos x, the LHS I'm talking about, times cot is cos x over sin x. And denominator will be cos x plus 1 over, cos x over sin x, that is cot x, right? Alright, is something, no, nothing is cancelling here. So, oh yeah, the denominator we have a plus, so we have to merge these two. So we can divide by sin x and multiply by sin x. Alright, so it becomes cos square x over sin x, and this one will become sin x cos x plus cos x over sin x. So this sin x and this sin x will get cancelled. Okay, so now what are left with? The numerator will be cos square x is 1 minus sin square x, that is numerator, this cos. Okay, now we can take sin x cos x. The cos x we can take common here. Let's take cos x common. So we'll be left with 1 plus, not 1 plus, sin x plus 1. Yeah, just like the previous I part, we can write this as 1 plus sin x, 1 minus sin x. Denominator is cos x, 1 sin x plus 1. They are exactly same, they get cancelled out. So we are left with 1 minus sin x over cos x. So let's separate the numerator now. So it will become 1 over cos x minus sin x over cos x. Yeah? And 1 over cos x is secant x. Sin over cos is tan x. And this is RHS. Identity 4a. Let's focus on LHS again, and we have done such a question earlier, so I'll do it fast. Sin x over cos x plus cos x over sin x. We have to prove that it is equal to secant x and cosecant x, so we'll take the LCM of the both by multiplying this by cos x, and here we'll multiply by sin x. So we are left with sin square x plus cos square x on top, and sin x, cos x as denominator, and numerator is 1. So will be 1 over sin x and 1 over cos x. That's how we can write it. Yeah, and 1 over sin x is cosecant x. 1 over cos x is secant x, and this is RHS. B. This will be here. 1 over 1 minus sin x. So here we don't have to simplify anything. there is a minus in between, 1 plus sine x. This is LHS. So they are different. So what we did in the previous A part, same thing we'll do here, but here we have to multiply by an expression, 1 minus sine x, which is the denominator on the other side, this one, and we multiply the denominator by the same expression. Similarly, 1 plus sine x, 1 plus sine x. Okay, now look at the denominator, 1 plus sine x, 1 minus sine x in both, and we know a plus b, a minus b is a square minus b square. So the denominator will be 1 square, which is 1, minus sine square x. What will be the numerator? 1 plus sine x on the first one, and minus 1 plus sine x. Why plus? Because there's a negative here and there's a negative here, both will become positive. So 1 and minus 1 cancel out. So 2 sine x over 1 minus sine square x. We can write it as cos square x. So let's separate this. 2 sine x over cos x. So the second cos x I will try to separate. Sin x over cos x we know is tan x, and 1 over cos x is secant x, and that is RHS. We proved it. Alright, let's go to C part. 1, oh, it is similar. 1 plus cos x plus 1 minus cos x. Okay, these are denominators, and that is the LHS, and we'll do exactly what we did in previous part. We'll multiply this with 1 minus cos x and this with 1 plus cos x. So it will become 1 plus cos x on top, 1 minus cos x on top. So the denominator now is 1 minus cos square x. Yeah, and 1 minus cos x first, and plus 1 plus cos x. Minus cos x and plus cos x cancel. We know 2 over 1 minus cos square x, which is sine square x, and 1 over sine square x is cosecant square x. So our final answer should be cosecant square x, which is RHS. Good. Alright. Let's see D part. D part says cos x over 1 minus tan and sin x over 1 minus cot x. So we have to convert tan x and cot x into sin and cos, so that we are left with something like this. Alright. Cos x over 1 minus sin x over cos x. And then we have second one plus sin x over 1 plus cot 1 minus cot x. So cos x over sin x. So this one we can write cos x over cos x. Yeah, so that the denominators are same. Similarly here we'll write sin x over sin x. So what simpler version it gives us? Okay, it becomes cos x on top, and it becomes cos x minus sin x. Yeah, cos x minus sin x over cos x plus sin x over sin x minus cos x over sin x. We know the denominator of a denominator is numerator. It multiplies with numerator. So this cos x will multiply with this cos. So it will become cos square x over cos x minus sin x plus sin x over, sorry, sin square x. Sin square, this multiplies with sin x minus cos x. Now look at the denominator. They are exactly same but reversed. Their signs are opposite. That means if I want this and this to be similar, I have to put a minus in front, and I can't put minus for free. I have to compensate it with minus on top. So this is what we'll do now. So on top now we have cos square x minus sin square x, and in bottom we have cos x minus sin x. Now we'll take the same identity we took for part A and B. A square minus B square, which is here. They are in format of A square minus B square. So let's write here, we can write them as cos x plus sin x, cos x minus sin x, divided by cos x minus sin x. Now this part and this part cancel. We are left with cos x plus sin x only, which should be RHS. Let's confirm. Which is. Let's move on to E. Again, it is this similar kind of denominator what is there in C part or B part. So something similar is here. So we can do it cos x over 1 plus sin x plus cos x over 1 minus sin x. So we'll multiply this by 1 minus sin x. Multiply this also by 1 minus 1 plus sin x rather. And same on top. Okay, so we are left with cos x 1 minus sin x plus cos x 1 plus sin x on numerator, and denominator will be a minus b, a plus b format. So 1 minus sin square x. Okay, we know denominator will be cos square x, yeah? Because 1 minus sin square x is cos square x. In these two, we can see cos x is here and cos x is here. So let's take cos x common. So what will be 1 minus sin x in the first one and 1 plus sin x in second one. That will be left out. This and this cancel out. Sin x and minus x. So 1 plus 1 is 2. So it will be 2 cos x over cos square x. This cos x will cancel with one of the cos. Now we are left with 2 over cos x, and reciprocal of cos x is secant x. 2 secant x, which is RHS. Let's do the last part, F. Okay, something similar. So cos x over cosecant x plus 1 plus cos x cosecant x minus 1. This is LHS. So we'll multiply again them by each other. We're doing the same thing again. Can you see? So rules remain same. And we'll multiply here by cosecant x minus 1. Cosecant x minus 1. Cosecant x plus 1. This should have been plus 1. Okay. Alright. So again, cos is common in both. So let's take cos common just like part E. So what will be left? Cos x plus minus 1 in this one. Cosecant x minus 1 plus. We have plus here, so no sign change. Cosecant x plus 1 from the second part. And it will become cosecant square x minus 1. We know there is an identity that this is cot square x. And here what will cancel out? Minus 1 and plus 1. So we are left with 2 cosecant x, right? So 2 cos x cosecant x. Still there is no chance of getting 2 tan x. That's what we want, right? But 2 we have, tan x is remaining. Let's see. 2 cos x, and let's write cosecant x now. It is 1 over sin x over cot square will be cos square x over sin square x. Alright, this sign will cancel with one of the signs. This cos will cancel with 1 over cos. So what are we left with? 2 is the only one in numerator, and cos x over sin x, which is cot x. Right? And reciprocal of cot x is tan x. 2 tan x, which is RHS.